Good morning, good afternoon. This is going to be your last Honors Algebra 2 video. It's one more topic that we need to do that it's not truly related to what we've been doing just recently, but it's something that you need to know. So what we are going to do, and you need a piece of paper so you can follow along with me, is we're going to do binomial expansions. Binomial expansions. Now, as you recall, binomial is two terms. So if you would recall, let's say we had x plus 4 and we wanted to square it. That wouldn't be too bad. Cubing it wouldn't be too bad. But what if we wanted to take it to the 5th power? Well, now it becomes a little bit more drawn out of a process. And so we have this way of doing it, and it relates to a thing called Pascal's triangle. Pascal was a physicist, mathematician, philosopher way a long time ago. So he has a triangle that he came up with, and we're going to create this starting right now. So at the very top is a 1. And then on the outsides, there's always a 1. Once we get to here, what we do is we start with a 1, and you go 1 plus 1 in through here, gives us a 2 with a 1 on the outside. Then you put a 1 out here, and then what you do is you take a 3 goes here, a 3 goes here, and a 1 on the outside. And the process repeats itself. We could go on forever. So what we have here is we have 1, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and always with a 1 on the outside. So the next row we start with a 1, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5 with a 1 on the outside. So let's just do one more. So this will be 1, 6, 15, 20, 15, 6, and a 1 on the outside. And this continues on and on. So this one would correspond to n is equal to 0. That's our power. This would be n is equal to 1, n is equal to 2, n is equal to 3. And you'll notice that it's these values as we go down. So this one is n is equal to 4, 5, and 6. And this would go on forever. And this is this exponent. So 5 would correspond to this row right here, the 5th row. All right, let's see how we do this. Let's say, for example, we want to expand a plus b to the 4th power. So the first thing that we're going to do is write down the coefficients, and the coefficients are these values. And I'm going to space them apart. So if I go to n is 4, I have 1, 4, 6, 4, and 1. Now the next thing that you do is with the first one, you start with this one being raised to the total power. So this would be a to the 4th. And then this would be b to the 0. This one, now what we're going to do is we're going to subtract 1 from the a's and add 1 to the b's. And since this is plus, all of these will be plus signs in between. So the 4 comes down. This is a cubed, b to the 1st. Plus 6a squared, subtract 1, add 1. 4a to the 1st, b cubed. Plus 1, now I don't need the 1 there, but I'm going to put it there, and I could put the 1 here too. This will be no a's, b to the 4th. Now when you go to do these, you do not have to put the 1s here, and you don't have to put the 0 powers, and you don't have to put the 1 powers there either. So if I were to write this all out, my final answer would have been a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. So what you'll notice is the a powers start at the total power that there is and decrease as they go across till there aren't any. And then the b's start at 0 with none of them, and then they go across till you have all of them raised up. Let's try another one. So this one is going to be x plus 5 raised to the 5th power. What I want to do is I want to go get the coefficients 1, 5, 10, 10, 5, and 1. So I'm going to write those out. 1, 5, 10, 10, 5, and 1. So underneath here, I'm going to start off with, I'm going to put an equal sign here for this. I'm going to start out with x to the 5th. Then I could do x to the 4th, x cubed, x squared, x, no x's. And the 1 would come here, the 5, 10, 10. The order doesn't really matter as long as you stay consistent. Now this is going to be no 5s, 5 to the 0. This will be 5 plus. This is going to be 5 squared. This one's going to be 5 cubed. This one's going to be 5 to the 5th. So when you multiply those all across, this is going to be x to the 5th plus 25x to the 4th plus 250x cubes plus 1250x squareds plus 3,125 x's plus 3,125. Now, hopefully I did the math right. If I didn't, you can understand, you can fix that. Okay, we're gonna do one more example. A minus 2b to the 4th power. Now what I want to show you is this is the same thing as saying a plus a negative 2b, the whole thing raised to the 4th power. So this right here, what's in the parentheses, is what's going to be substituted in. So I'm going to go up to the 4s and I have 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay, so this is going to be a to the 4th. I'm going to put a cubed here, a squared, a, and no a's. I'm going to put a 4 in front, a 6, a 4, and I'll just put the 1 there. All right, I'm just going to put plus signs. The signs are going to generate themselves when I substitute in what's happening with the negative 2b. So there aren't any negative 2b here, 2b's here. So I have the plus there. So this is going to be minus 2b to the 1st. This will be minus 2b squared. This will be minus 2b cubed. And this is going to be minus 2b raised to the 4th power. So you can see every other term is going to be negative. This one's just going to be a to the 4th. This one's going to be minus 8 a cubed b. This one is going to be plus 24 a squared b squared. This one is going to be minus 32 a b cubed. So this is just simplifying. And this one is going to be plus 16 b to the 4th. And you'll notice it goes no b's, 1b, 2b's, 3b's, 4b's. A to the 4th, a cubed, a squared, a to the 1st, no a's. And then you just have to combine these terms, multiply them out. So it's pretty straightforward if you follow these directions. So your homework, I'm going to put up here, is going to be to expand. And I'm just going to have to do 4 of these. The first one is x plus 3 to the 5th. a plus 2b to the fourth, 2x minus y to the fourth, and 5 minus 2y cubed. So those will be that'll be your homework. And again, this is called Pascal's triangle. Pascal was famous in math and in physics. In physics, he has a unit of pressure, all defined for himself. A Newton per meter squared is a Pascal. Okay, well, this is our last video, and I would like to just turn this around if I could. I can't, so I'll do it this way. I don't know if you can see me. I just want to tell you thank you for a great year, and I know this looks really terrible, but you guys have been awesome, and I look forward to seeing you in Honors Physics next year. Take care, have a great summer. Love you guys. Bye.